thing that I love the most about research is when we do new experiments, we get to observe new phenomena for the very first time that no one's ever seen before. And that's really exciting because very often you don't understand what you're seeing, but after you spend lots of time and think about the observations, do follow-on experiments, you eventually get to learn new things that were previously unknown. And that's just really exciting for me. The main reason that I've pursued a career in academia is that I really enjoy the freedom that I have at work to explore different directions and set my own agenda for research. So as I was saying, we sometimes see these unexpected findings, and then it's really nice to be able to go into those in more detail without other constraints holding you back. Our research develops new materials that can help with climate change mitigation. One key area that we're working in is carbon dioxide capture. Here the idea is to remove carbon dioxide that's currently being emitted into the atmosphere and causing global warming and climate change. So here we work on both new materials but also new energy efficient processes for doing improved carbon capture. Our research has two main areas of impact. Besides firstly developing fundamental knowledge that can help the field progress new materials, we're also developing new materials ourselves, with our goal being to eventually get those out into the real world, and as I said, to mitigate greenhouse gas emissions. One project that we're just starting at the moment is on new methods for carbon dioxide capture that use electrochemistry. So traditional carbon capture uses porous sponge-like materials to absorb CO2 from places where it's emitted, and then heat energy has to be used to then regenerate the material and release the CO2 for sequestration or for conversion to useful chemicals. With the new approach, we use electricity to do this process. So we take an electrochemical cell, like a battery, and when we charge it, that brings about carbon capture. And then when we discharge it, we release the carbon dioxide for utilization or collection, for utilization or conversion. And the whole process is then more energy efficient than the traditional approach. So we're working on fundamental understanding on these processes, but also the development and application of new materials with improved properties. Another area that we're working on is energy storage. So for example, we're working on fast charging energy storage devices called supercapacitors. And there we're trying to develop, again, improved understanding on how these devices work so that we can ultimately then increase the amount of energy that they can store while maintaining very fast charging and discharging times. Our focus in the group is on porous materials where the pore size is around the same size as a single molecule. And so we work on materials such as metal organic framework materials, which are essentially like Lego materials where you can build different blocks together and end up with a porous structure. And in particular, we put specific functional groups in place to then absorb carbon dioxide or to store energy or serve some other function. One major shock that I found when I started my PhD research was you go from an undergraduate program where you have so much structure and everything is really laid on for you in terms of what you have to do hour by hour. And then you go to doing a PhD where you have just this immense freedom to manage your time and research. And I think I found that a real challenge. One thing we're doing now in my group is having group meetings on professional development, which supplement the graduate education program in our chemistry department. So we talk about issues in our group meeting like time management and things like how to give a good presentation and how to keep up with the literature. And so that's been going on over Zoom this summer, and that's something we'll be continuing in the future. With the current situation, we've been having our virtual meetings and having regular meetings just so that we're all in touch. And we use the breakout room feature in Zoom so that we can have these one-on-one interactions that we might be missing out on otherwise. In normal times, we do also go out for group lunches and activities like that, but we'll have to see how that progresses in the new year.